Hello, 8th grade science. This is our third instructional video for Unit 5, Week 3, and this follows kind of your last activity, last big idea that we're learning about called analog versus digital signals. So analog and digital signals, we've been learning about them really throughout this whole unit. We just haven't specifically called them that, and you'll kind of see that in your assignment later today. The goal of that assignment is to learn the difference between the two, and then also be able to explain why digital signals are used based on their properties, which is we'll kind of touch on in the assignment. If you look at the lesson plan part, there is some bell work that's linked as well as a CFA at the bottom here. This video does a really good job of explaining the difference between the two. And then there are some notes that I'm going to have you take. If you look here, make sure you do your checklist of things to turn in on Google Classroom as well as your CFA, and you should be good to go. So if you look at the notes, here's the notes. These are set up a little differently. So you're going to be typing essentially in 4 boxes. So you're going to tell me what digital signals are, analog signals are. You're going to write about what's happening to analog signals over time versus digital signals over time in those 4 boxes. And these, where you get the information, if you click on this link here, it's set up a little differently, but they kind of have information the same way. So anything that's pink text, this is what you would type onto your notes. So first thing, analog signals. They're just continually changing signals that represent information. So a lot of these are used in what I consider more older technology, a cassette player, a film camera, an analog, really old school television, your analog clock. Those are older school type things, but they all are a way to, they house or store information by changing some sort of signal. So in this case, when we're talking about a cassette player, it uses that film, and that film has different things on it. Actually, I'm more familiar with this, I guess. I'm not sure what's on the film, but like in a digital camera, like I don't know if you guys ever had, or a film camera, sorry. If you ever get out like it's like this like kind of brown blackish strip, and you can kind of see the images that you took on the film, but they're not like, they're kind of weirdly colored. That's kind of an example of this analog signal. So it was capturing what the light was telling it when it took the picture in this kind of almost weird looking way, and then we use that to actually make the photos back in the day. And so these are older school technology, but we still use analog signals all the time. I'll kind of explain that here in a second. Digital signals, on the other hand, are signals, information. That's what that means. But instead of always changing all the time for that information, they use essentially digits, computer code, to represent that information. So a digital camera, right? We don't use film in that. It has computer code that represents the image that I just took. That Spotify song, it's not necessarily like if you think of like a record or even like a CD, right? It's not a certain spiral pattern on my record or my CD. It's computer code. That song's been digitized, and that's how I stream it, to listen to it. So those use digits, computer code, to represent information. That's kind of the difference between the two. One uses that computer code and one doesn't. It uses just essentially waves. And here's kind of the thing that we learn about. So analog versus digital. If you look at analog, let's pretend that this is like music, right? So we have just a simple sound wave. So it might use sound to record that information, such as a record player listening to a song has a sound wave there. But digital, it kind of does it a little differently. We still have that kind of wave pattern you can see, but it has it more in this digitized type code is what you could call it. So it's trying to represent what an analog signal does, but in a little bit different way. When we compare the two, so analog transmission, so trying to listen to things from analog, the bad thing about it is that it gets worse. It breaks down over time, making it not as reliable. So if this were my original signal of an analog, maybe it's a song being transmitted, over time it's going to get reduced. It's going to break down. So for example, if I had a record, sometimes records can get scratched. Sometimes they're just going to wear down or break over time because they're not necessarily made to last that way. So it can result in poor quality transfer of that information that it's trying to store. Versus digital, we don't really have that degradation. It's all computer code. So if it does somehow get damaged, we can restore it back to, its original source, and it's going to be fine. That's why a lot of times we have higher quality transmission. We can get HD TV now and things like that from these digital signals that we couldn't with analog signals. And so it makes things a little bit nicer and better for us in the modern day. This is what yours should look like filled out at the very end. And you should be good to go there then. I'm going to go through how to do the assignment in the direction video here, and you should be good to go. Have a good rest of your day. Bye.